exploring unknown tech, decoding future unicorns. Welcome to Product X, using the sharp intuition of capital and the hardcore logic of an architect to help you catch the next big event in the global tech sphere. Hello everyone, I'm Rena. In the midst of the current AI and spatial computing frenzy, tech giants are throwing tens of billions of dollars at NVIDIA high-end GPUs to train generative visual LLMs and run incredibly complex 3D physics simulations. However, many CTOs are waking up in despair to find that the utilization rate of their exuberantly expensive GPU clusters often hovers at a pitiful 40%. For the rest of the time, the GPUs are essentially waiting in line for the CPU to feed them data. To eradicate this insanely expensive compute waste, a San Francisco-based underlying performance infrastructure startup named Superluminal officially announced today that it has raised a massive $22 million Series A financing round. The lead investor is Benchmark, the veteran top-tier Silicon Valley VC, famous for its extreme selectivity and its philosophy of exclusively backing foundational infrastructure companies. Vivian, want to kick us off?
Hey, Rena. Thanks for having me. I'm Vivian. I work as a senior angel investor at Pre-Angel Fund, and I'm really excited to dig into this one because it's exactly the kind of infra play that gets me buzzing.
Nolan, your turn.
Hey everyone, I'm Nolan. I used to work as a CTO and top architect at a couple of big tech companies in Silicon Valley, so I'm looking forward to breaking down what's actually happening under the hood here. This is some seriously deep technical territory.
All right, let's get into it. Vivian. While everyone else is chasing flashy foundation models, Benchmark just dumped $22 million into an underlying tool that helps programmers find performance bugs. What is the capital calculus behind this move?
To understand why Benchmark led the round for Superluminal, we have to first unearth the technical origins of this company, alongside the most agonizing financial ledger currently plaguing the AI industry. The founder, Ritesh Oidirajing Varma, is an absolute god-tier geek within the elite global C++ and Rust hardcore game development communities. The profiler he built has been spread by word of mouth among developers for its absurdly fast loading speeds and extremely low system overhead. Here's the thing. Today, a startup building physics simulations or video LLMs might run up an annual GPU bill on AWS or Azure, reaching tens of millions of dollars. If engineers use Superluminal to precisely pinpoint a memory lock or thread block in the underlying graphics API, thereby boosting code execution efficiency by just 15%, it doesn't just mean model training times are slashed by months. It means millions of dollars in pure profit drop directly to the bottom line. Benchmark isn't investing in a simple bug-finding tool. They're investing in the software infrastructure that allows every AI and 3D engine company to extract maximum ROI from exuberant hardware.
Right. And that's where the technical story gets really interesting. Let me jump in here. From the underlying systems architecture perspective, troubleshooting performance bottlenecks in 3D rendering and high concurrency visual models has always been a hell-tier difficulty. This is because you constantly collide with the famous Heisenberg effect. When you use a traditional profiler based on instrumentation to inspect code, the tool itself injects timestamping functions before and after every single line. This generates massive system overhead, causing the program execution to slow down drastically. Consequently, microsecond level stuttering, originally caused by multi-threaded race conditions, miraculously disappears because the execution timing is altered. You fundamentally cannot catch the real bug. Superluminal executed an incredibly hardcore asymmetric strike. They abandoned heavy instrumentation. Instead, they hooked directly into the operating system's underlying interrupts and the CPU's hardware performance monitoring units. They take snapshots at an incredibly high frequency, thousands of times per millisecond. This technique exerts almost zero performance interference on the original program. Overhead remains in the low single-digit percentages. The flame graph the developer sees represents a 100% accurate physical latency distribution in a true production environment.
Nolan, you just dropped some serious jargon there. But wait, how does this actually help with the CPU-GPU coordination problem that everyone's complaining about?
Great question. The core pain point in generative visual models and physics simulations is the coordination between CPU and GPU. We can model the total execution latency using a classic equation where total time equals the max of CPU encode time and GPU execute time, plus the PCIe transfer time, plus synchronization overhead. More often than not, when the GPU is idling, it's because the CPU side encoding has encountered severe multi-thread lock contention, or the data transmission across the PCIe bus is congested. Superluminal's killer feature is achieving microsecond-level absolute alignment of CPU thread activities and GPU kernel execution instructions on the exact same timeline. A developer can see at a glance, at this exact microsecond, the GPU is waiting because CPU thread 3 is blocked waiting for a memory lock.
Vivian, from where you sit in the investment world, what makes this defensible? Why can't a big player just copy this?
That's exactly the right question to ask. In the developer tooling space, survival often hinges entirely on delivering an extreme user experience. Let's contrast this with the current solutions. Legacy general-purpose profilers like VS Profiler or gprof have high system intrusiveness. Instrumentation mechanisms severely distort the true latency of high-frequency 3D and AI applications. Native heavyweight hardware tools like NVIDIA Nsight or Intel vTune are tightly locked into their own proprietary hardware ecosystems, weak cross-platform capability, and the UI is bloated. Loading trace files from massive clusters often takes minutes. Superluminal delivers extremely low overhead based on non-intrusive hardware sampling, supports cross-hardware unified CPU-GPU timelines, and has a native-built extreme performance UI that delivers millisecond-level smooth zooming across massive trace datasets.
Let me add to that. The comparison really undersells how hard it is to build what Superluminal built. The real moat is the engineering talent. You need people who understand both the hardware-level PMU internals and the developer workflow. That combination is incredibly rare. It's not just about the algorithm, it's about the years of refinement in the game dev community that gave them the intuition for what developers actually need to see.
Okay, let's talk about the money angle. With that $22 million Series A, what's the next move for Superluminal?
With this funding, they're backing the team's move to establish headquarters in San Francisco and aggressively attack the enterprise market. Benchmark's classic picks and shovels strategy is at play here. In a gold rush, these foundational infrastructure tools historically command exceptional customer stickiness and massive pricing power. Every company that's training visual LLMs or building physics simulations is a potential customer, and once your profiler is embedded in their workflow, you're incredibly hard to replace.
Nolan, from a technical standpoint, what's the biggest challenge they face now?
The next epic engineering challenge will be the leap from single-machine, single-node profiling to distributed topology profiling across hyperscale AI clusters. When future physics models are deployed across networks consisting of thousands of GPUs, performance bottlenecks will no longer be confined to the PCIe bus. They'll bleed into the fiber optic switches of NVLink and InfiniBand fabrics. Extending this microsecond-level sampling technology seamlessly across a distributed training graph spanning thousands of servers, allowing developers to oversee the entire compute blood flow of a supercomputer on a single, unified UI, that will be the ultimate battle, defining whether Superluminal can forge a $10 billion infrastructure empire.
All right, let's do a quick lightning round. Quick-fire questions, quick-fire answers. First one. Vivian, if you could summarize Superluminal's value prop in one sentence for a skeptic CEO, what would it be?
It literally pays for itself in weeks because it'll save you millions in GPU bills.
Nolan, same question but from a developer point of view.
Finally, you can see exactly why your code is slow without making your code slow.
What's the wildest thing you've seen a company waste GPU compute on?
I saw a startup running 200 GPUs to render a demo that was ultimately 30% idle the entire time because of a single blocking call in their pre-processing pipeline.
I've seen teams copy entire datasets to every single node because nobody bothered to check if the data loader was actually doing what it was supposed to do.
If Superluminal had existed 5 years ago, what would you have used it for?
Honestly, I would have used it on every single shipped product we had. The debugging cycles we went through, the amount of time we burned trying to reproduce production issues and staging, it would have cut months off our release cycles.
I would have forced every portfolio company to run it before they did any Series B financing. The efficiency gains are that obvious.
Last one. Hot take time. Will performance tooling be the next big VC category?
Absolutely. Compute is only getting more expensive. Everyone's scrambling for GPUs, but nobody's optimizing what they already have. That's a massive market gap.
I'll slightly push back. The market's there, but execution is everything. It takes a special kind of team to build this, and Superluminal has that team.
Vivian, give us a one-sentence summary of today's episode.
Superluminal is the picks and shovels play that turns GPU waste into ROI, and Benchmark just bet big that developer tooling is back in style.
Nolan, your one sentence.
They built the only profiler that doesn't lie to you about what's actually killing your performance. And that's worth billions in a world where compute is the new oil.
Thanks to Vivian and Nolan for joining us today. If you want more deep dives on the infrastructure wars reshaping AI, hit subscribe and stay tuned to Product X. We'll see you next time.